For this problem, we're given a function g, defined as the absolute value of x minus 4, and asked to graph that. And they don't specify over what values to graph it, but they want us to come up with the domain and range of this function also. Well, before we graph it, we can look at this and see what the domain is. All real numbers are in this domain because you can take the absolute value of any real number. So any value can go where x is. So this function is defined for all real numbers, so its domain, all real numbers. I'll put all real numbers. And remember, there's a symbol for that, which, or you could write it in interval notation, everything from negative infinity up to infinity. Okay, anyway, to graph this function, which is, we'll graph it before we decide what the range is. Let's make a little table of values. So we'll have an x and a g of x, which will be our y-coordinate. Remember, the output is graphed as the y-coordinate, so y is always equal to the function of the x input value. So anyway, let's start off with negative 4. If x is equal to negative 4, what is the output? What is the absolute value of x minus 4? So we'll figure that out here. G of negative 4, putting an input of negative 4 into this function, is the absolute value of negative 4 minus 4. And that's 4 minus 4, because the absolute value of negative 4 is positive 4. So that's 0. The output is 0 at negative 4 input. Let's next try negative 2. G of negative 2 is the absolute value of negative 2 minus 4, which is 2 minus 4, which is negative 2. So when the input is negative 2, the output is also negative 2. Notice that g doesn't change negative 2. G changed a negative 4 into a 0, but a negative 2 remained a negative 2. Let's try 0 next. G of 0 is equal to the absolute value of 0 minus 4, which is 0 minus 4, which is negative 4. So that's negative 4. And finally, let's keep going. 2, when x is equal to 2, g of x, g of 2, becomes absolute value of 2 minus 4, which is 2 minus 4, which is negative 2. So when you input a 2, what's output is a negative 2. Finally, let's do one more. Input a 4. So g of 4 is the absolute value of 4 minus 4, which is just 4 minus 4, which is 0. So that's plenty of points to graph this function. So notice the x values go from negative 4 to 4, and the y values go from 0 down to negative 4. So let's graph that. Notice the y values are all below the x-axis, except when it hits the x-axis. So let's put the x-axis here, the y-axis here, the vertical one, y. And then the x-axis will be toward the top because the graph is the part of the graph we're looking at is below, mostly below the x-axis. So we have negative 1, negative 2, negative 3, negative 4. And 1, 2, 3, and 4. And at negative 4 we're at 0, so we're right here on the x-axis at 4, negative 4, and also at 4 on the other end. Then at negative 2 we have to go down to negative 2, so let's go negative 1, negative 2, negative 3, negative 4. So here's negative 2, so we go 2 to the left, we have to go down 2 to get to the graph. And if we go over 2, we also, notice, 2 also has an output of negative 2. So we also have to go down 2. And finally, when the input is 0, the output is negative 4. So that's this point. Therefore, we can graph this function. It comes like a straight line down. and then it sort of reflects and goes up. That's the characteristic of these absolute value graphs. They tend to have V shapes. As we can see here, it's clear what the V shape is. So, now we have to figure out what the range of this function is. And notice that these lines will keep going. So let's see what the range is. The range is all the possible y-coordinates that this function can have. And you see the output can be very large. Say if x was 1,000,004, the output would be 1,000,000. If x was 1,000,004, the output would be 1,000,000,000. So the outputs get arbitrarily large. The y value, so the second coordinates, the y-coordinates, become arbitrarily large. That's the range. So the range can get as large as you like. How small can the range be? I see that there's y-coordinates on this graph all the way down to a y-coordinate of -4, but below -4, there's no point on the graph. So the minimum y value is -4. That's the minimum of the function. Therefore, the range of this function must be all real numbers from -4 up to infinity. So in interval notation, we could write that as -4 to infinity. Or you could say this is the set of all y values, real numbers y, such that y is bigger than or equal to -4.